about an hour and a half away. And it was just pouring out. So I'm surprised there's a couple people stayed at home.
Hello.
Hi, Dr. Philin. Good evening.
Good evening. How are you?
I'm fine, thank you. How are you too?
Doing good. Doing good. Okay.
Hello, Professor.
How are you?
Good. Okay. Tired, little bit.
Hello, Sarah. Hello, Lina.
Hello.
How are you this evening?
Good.
So here is Boston. Hello, Boston.
Hi, Boston.
Hello, Steven. Yeah, thank you much for keeping investment of your time into this course and surviving homeworks and schedules of presentations. So today I'm going to show everything which is left over from not included in previous ones. And to my memory, it should be K points, then anions, cations, excited state, and then singlets and doublets and triplets, right? Okay, so if I miss something, please let me know, and I'll try to go forward. Another, yes. I do have two options. One is to just make long stops and make sure everyone is on the same page, or just rush through and make sure we complete everything in time, or maybe trying to do a balance. So please try to log into at least to open at least two terminals, one on the port and another on the Ori on the nurse through for them. And the first thing I'm going to show will be the K points. Is it Lina who will show it on Tuesday? Momentum dispersion. Right?
Yes.
Okay.
Yes.
Okay. So the start share screen right away. So during this little exercise, I will apply this skill towards titanium dioxide nanowire, but in the last serious homework, you will be invited to apply it to other polymers. So what is shown here? This is energy of HOMO and LUMO, but you see they are not constant. They are changing with momentum. So there is a chance that if the molecule is periodic, so if it is nanowire or polymer or two-dimensional material or bulk, that even in ground state, electrons have non-zero velocity. Means they are constantly moving with certain speed. And the same orbital may have several implementations. So HOMO can be like at zero, it means it is steady HOMO that sits. And with non-zero momentum, it means like traveling HOMO. Okay, and by the matter of fact, the energies of HOMOs and LUMOs do depend on this parameter. This dependence is very different in a range of materials. So the example here is maybe 30% of material show this behavior, but there are drastic deviations. So typically, not typically, but in like 30% of cases, the energy of volume increases as you ramp up the electron, and energy of hole decreases as you ramp up the hole. And if one tries to feed it, it looks approximately like momentum squared. So this, especially for the LUMO, this would be implementation of kinetic energy, which is momentum squared over two masses. So if the velocity of electron is quicker, then the energy will go quadratic. But it is not an absolute law for all materials. There are very exotic dependencies. And if one has more than one directions of periodicity, it can bring a lot of surprises. So who of us may need it for the project? Those who will look onto periodic, just a second. It is important for metals and semiconductors. If you're dealing with insulators, you do not need it for sure, even if your model is periodic. Like if you deal with glass, transparent crystal, one can neglect it. If you work with standalone molecule or quantum dot, you do not need it. But if you are planning to deal with two-dimensional planar material or a polymer, especially conjugated polymer, this skill is needed for your research. So how this, the name for this curve is referred to as momentum dispersion. I do not think it is a good selection of terminology, but it is what is accepted in the community. Dispersion, because it like disperses, it depends on momentum. So please stop me anytime. I will try to speed up myself to go forward. So if you, and I will start doing it right on the NERSC, but the commands are the same, and then I'll just transfer things to the photon. No, I will open a new directory so I do not do any cheating. So you see me do it straight. Make directory periodic.
So, Doctor, do we need to make a directory on NERSC too?
Yes. Well, this calculation is not super demanding. You decide where would you like to run it. So if you hate NERSC, you are welcome to do it on a photon.
Okay, so we can do it on photon.
If you really like photon, and if Stephen permits.
It's the direct. We are familiar more with the directories on photon.
Yes, I will do demonstration on NERSC because it's a little bit more comfortable for me, and then I feel more power to run bigger jobs right away if needed. But this, I don't care where you do your calculations. You can do it on CCAST, photon, or NERSC. Now we care only about the results. And how to say, hints, there is a little directories with hints are exactly the same or very similar in both photon and NERSC. So I did open the new directory. You see it is empty, and I'm copying the Oscar, okay, points, and in car. So into this directory, and I'm also copying this debug message. So a little note, well, you're welcome to copy whatever I'm doing, but please do not copy blindly, do as educated copying. So especially if you switch from one atomistic model to another one, the pod car, the file for potentials, will be not valid if you transfer from titanium dioxide to silicon or from silicon to hydrocarbon. Each time you need a new pod car associated with for specific elements. I just noticed errors in the past homeworks. So if one inherits pod car from different system, the results will be too congenial, not appropriate. Okay, now the I do have 4 files from VASP and 1 file from NERSC to run the stuff with minimal resources. It is important for dispersion that it is VASP standard. You may check, there is a VASP gamma, VASP underscore gam, which will fail for dispersion. So standard means gamma is a little bit quicker, but it doesn't have full capacity. And there is a third version of VASP, NCL, non-collinear spin, which we are not going to use in this labs and class, but it is quite useful if you plan to do competitive research about magnetic materials. So debug is okay. Now,
Dr. Killing,
yes.
where are we copying this from? This CI4, or is it from the last lab?
Yes, I copy the model from 2 weeks ago, before molecular dynamics, when I did some like absorption and density of state. So it just optimized model of titanium dioxide periodic. And if you want, you are welcome to SCAR. You're welcome to copy models directly from my directory. Right now, I don't care about the structure, and you already passed skill of building models and show that you can do something. Now we focus only on processing the model. So 8 plus 4, 12 items. Okay. So for the in-car, I do not have anything ambitious. It is, yes?
I just saw that in your that NASC, their anion cation. So in the I remember that in the last class you didn't show us this kind of thing. So how?
Yes, they are empty, and I'm going to show them next.
Okay.
The points, the dispersion is the first, because it takes a little bit more time than the rest. Others can be done maybe 5 minutes per exercise, and the dispersion will take like 20 to 30 minutes. Okay, so the in-car is a copy from geometry optimization, a single point. So NSW
Another
0.
question, Professor.
Yes.
Sorry to interrupt you. So if you want to show the anion cation today, so you can start from the photon. We did lab 10 in photon also, right? So you can start from that one.
The commands will be absolutely the same. You can do it on any server.
No. My question is that why you copy from the another server?
Yep. The input files will be absolutely the same.
Hmm.
And why personally I prefer NERSC? Because it's my personal preference.
Okay.
But there will be no difference. The photon, well, I do not want to overload the photon from myself, even with small tasks. But there will be no difference in anything I'm telling now. So the in-car is standard for single point or geometry optimization, and the pod car we checked. Grab the pod car. It is appropriate for titanium dioxide, and the only file that I change is K points. So in the place where we typically have 1, I put 16. And I'm putting 16 because I'm humble. And I do not want to waste resources. But if you do it for like publication, you can put like 100, 200s, especially if it is a single point, if you want to find a grid for interesting result. Save WQ. And then after I checked that this key points file is okay, I am submitting the job and waiting until it is done. Yes.
In a photon, not photon, NARCs, there R means running, right?
R means running, yes.
CG means complete.
When it is CS, it is close to completion.
Okay.
PD means pending, R running, CS close to completion. Yes, Boston.
You change the K points, just change the one value. So that would change things like
Corresponding to a direction of periodicity. If the model is periodic in X direction, I change K points along X. If it will be grown in Z direction, I will change number of K points there. If it is two-dimensional along X and Y, I would make equivalent number in X and Y. So the job is done. And yeah, so the job is not running anymore, and I can check tail out car. It shows that the job is done. So what is specific in this calculation? So if I look through out car file, so there are iterations of electronic structure optimization that we covered yesterday in the class. And after they're done, we see the stuff that we typically expect. So Fermi energy, and then a list of orbitals. But, so here is hocus pocus. I keep going from here, and I expect that it will be done about now, end of the list. But oh, there is a K point number 2, and there is another list of orbitals. Same as if it will be another system in here. Then going further, there is a K point number 3, and there is another list of orbitals. And it is repeated. Well, instead of 16, it does 8 because it wants to make system more symmetric. So there are several lists of K points, and if one looks closer on these numbers, so 32 is HOMO, 33 is LUMA, the energies of HOMO and LUMA will be different at each value of K point. So to interpret this data means that at each k point, which means at each value of momentum, one considers system constantly moving in the x direction with certain velocity. And depending on this momentum, on this velocity, the energy of each orbital is updated. So our practical goal is to extract energies of this orbital 31 and orbital 32 as function of the value of k point. So we need the value of momentum in dimensionless units is stored here, and the argument that we want to plot along y are in the orbital energies HOMA and LUMA, which are 32 and 33 for this specific model. If you apply to different models, the numbers will be different.
Dr. Kevin,
Yes.
sorry, which of the files did you say is carrying the momentum again?
Can you please close the microphone closer, just a little louder?
Which of the files did you say contains the momentum?
Okay, thank you. I'm looking for file outcar. So it includes most of information.
Okay.
When I need to run the job, I modify the file k points. When I need to inspect output of this job, I need to look into the outcar. And by now, I believe everyone understands the principle, right? But there is a technical challenge how to extract these numbers out of this file and how to plot this dispersion curve. We see like -7, -3 something. What's the meaning of k point? Boston, can you try?
Well, my understanding of it, not necessarily right, is different sampling points in the Brillouin zone or different.
Be simple without terminology.
Just different sampling points of momentum in the system. And the energies might be a little bit different at different momentums. So you need to get an accurate result, you want to try and sample as many different places as you can, and then.
What's relation between momentum and k? Why the letter k is used?
K is the wave number of in quantum mechanics, that would be the wave number of.
So how wave number is connected to momentum? Is it like momentum divided by Planck constant?
Yes.
So they're proportional,
Yeah,
linear.
H bar is in there, yeah. It's proportionally to momentum. I forget what the actual constant proportionality is.
Planck constant. Kate, did Boston satisfy your question, or you need a little more? There is no reply? More. Huh.
Yes, I'm satisfied. Thank you.
Professor, I'm not able to listen anything. What happened?
Oh, Baron?
No, now it works. Oh.
So the simplest wave function is times some additional dependence on x. And this p divided by h is referred by letter k, right? So the quicker the velocity, the more dense fringes of the wave function. So in addition to typical form of orbital, one has this imaginary part which we will not see if you plot per charges. If you take absolute value square, if we plot if you plot this phi sub k absolute value square as function of position, it will look the same because this phase factor cancels. But it brings contribution to the energy, and in periodic materials, it is really important. So it's good that Kay, you are asking about it, because in conjugated polymers, it is an important factor. Is it a little bit better?
This professor, now it's okay. It's okay. Now it's
Okay.
okay.
Okay, thank you. Let's go back to the practical things. I'm just looking for the razor. So we need to extract these numbers, and there is a I do have a little cheat sheet. Let me share it in the chat to everyone. And there are several versions of this cheat sheet. If one put instead of titanium 408, there are different versions. So there it shows it. And I was trying to avoid writing a script or command because there are too many things that one needs to change dynamically. But this protocol is quite quick. So the first command is to extract values of the momentum. So what it does, it looks for the keyword key point and then extracts the record number 4. So first record, second, third, and fourth. So, and from here, we do need last 8 things because they are not repeating. So let me copy into the chat line. So if I look now more,
Professor Killian,
yes.
sorry, why did you say we need the last 8 numbers? I don't understand what you said by because it's not repeating.
So here it shows the same pattern of numbers twice.
Okay. I see.
It goes this 0.03 and 8 numbers, so that's 0.03.
Again. Yes, okay.
So I need only last 8.
Okay.
Okay, and this file KK has this value of moment. Now I'm going back to this cheat sheet. And if I practice the command here, it will extract energies of orbital HOMO for each K point. And you see these energies are different, right? But we do not need the index of orbital, and we do not need the population. We need only the second column. Therefore, we will practice the command. So we extract the line containing number 32 from the out car, and then from this line we use only the second column, and we direct it into the file K32. More K32. So it is the same number starting from -6.9 ending -7.2. So let me copy the command also to the chat line. Second, okay, I do see your question, and I will answer momentarily. So more key points. So in this statement, we tell that we wish to have 60 points, but Rust itself has the procedure which called automatic mesh, which tries to make number of key points a little smaller to speed up calculations. If we want to decline this option, one should type direct mesh, and then it will be 16. But just by inspecting the outcar file, I do see that the number of key points is twice as less than the requested number. Boston, in your practice, do you know which file contains this information? Okay, I think it is something that has Brilliant Zone in its abbreviation. IBZ. Yes, yes. So if you look into this file IBZK points, it shows how it answers the how many key points is used in this calculation. So it is answered to question by K. So we requested 16, but Rust decided that it wants to use only 8. Here they are. Okay. So I'm going back to this cheat sheet. And I do want also energies of the LUMOS, which are orbital numbers 33. So I extract lines with number 33 from the outcar, and then this vertical line means transfer output of this Linux command to the next Linux command called piping, and then this text processing AWK tells use only the second column, and then we forward it into the column 33. More 33. It has this energies of moves. And let me copy the command into the chat line. Paste. Enter. So now I'm going back to this little cheat sheet. And my next wish is to merge these three columns. So I have column with value of momentum, column with energy of orbital 32, column with energy of orbital 33 into single file that I can plot with either Microsoft Excel or GNU plot or whatever I like. So PR is merging several columns into one file. Copy, paste. So more KK. So first column shows value of momentum, second energy of HOMA, third energy of moment. Okay. After the class, show how do you get that dimensionless graph. No. I will show it during the class. It's for everyone. It's not a secret to be told after the class. Oh, no, it should go to everyone. List. Okay. And now I'm going back to this cheat sheet. And it has this command GNU prod with some quick script. So I can paste it here, and just for your curiosity, I can quickly.
Professor,
Yes.
what's the
Yes, Kay.
is there any meaning of KKE, or it's just you write and define it like that way?
Is there a meaning of the dispersion, or is there a meaning in abbreviation of the file name?
Meaning of dispersion. That one is the file name.
It shows how the energy of orbitals depend on momentum. So, Sarah, did you read the manuscript by Amir, or maybe he was reporting his manuscript on the group meetings of Professor Shah group?
Yes, I just took a look and go to his figures.
Can you try to address question by Kea? Like, yeah. Why momentum is important? For which observables in real life the momentum is important? In application to conjugated polymers.
I don't know the answer.
That's okay. That's okay. It's challenging. Boston, would you like to give some simple comment why dispersion is needed? Just try some fantasy, some hypothetical, like direct, indirect, direct and indirect gap. What does it control?
Oh yeah, the direction of the gap is dependent on which way you're looking the Brillouin zone, and so in order to determine that, you need to have a good sampling of different directions.
Okay, not wrong, but maybe one may need a little bit more. So, okay, thank you for doing this important, how to say, not provoking, but stimulating questions. So, if we want to look how the system absorbs light, then even with HOMO to LUMO, it can absorb at energy 1, it can absorb at energy 2, it can absorb at energy 3, and it means that the absorption spectrum, instead of a sharp line, it will get broadening because of momentum dispersion, because several transitions are hidden inside one. So it is one use of momentum dispersion. Another, if the minimum of the LUMO and minimum of the HOMO coincide, then it is called, as Boston taught us, direct gap, and it is optically active. But some materials show crazy dependence. For example, this minima and maxima do not coincide, and such materials do not emit light at all. And looking on the dispersion curve for a specific material, one can immediately say whether it is a reasonable light emitter or it is not emitting light at all. So for molecules, for isolated molecules, it doesn't matter. But for periodic conjugated polymers, it is a critically important feature. Okay, did it answer your curiosity to some extent?
Yes.
Okay, yeah. Thank you. Going back to this cheat sheet. So GNU plot this little script, copy, chat, paste, enter. The script does nothing but plots this file KKEE. I'm responsible for this name, and it is not most elegant. I just used double letter because it is several Ks, and double E because there are several energies. So first it is HOMO versus momentum, and second is LUMO versus momentum. So second and third columns. And upon practicing this command, there appears a file band homo-lumo.ps, which we can process as ps2pdfwr band homo-lumo.ps, and then we have this file in the form of the PDF. And if you were doing this on the Photon, you can immediately download the file. If one was doing it on the NERSC, one needs to transfer files from NERSC to Photon, and I'm just lazy to type this command over again. I will use the template. So I'm copying everything from Lab 11 directory on NERSC into Lab 11 directory on Photon. So while implementing this command, if you plan to implement this command in your cases, please change the names accordingly. And if I type enter, I give the name. And it transfers files. And I can on Photon find this directory PLE and have this band homo-lumo. I just need to erase oh, trash. Just quickly. And a little smaller. So it basically gives the same figure as you saw before. So please try to practice if you think it is important for your project homework or presentation. I'll do a quick tour over sheets and ask you to share screen. And Lina is the first priority because she needs to present this this subject. And then I will quickly go over modification of electronic configurations, which will be much quicker and simpler. Before starting the tour, I want to make everyone co-host. Yes. 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 bottom, you comfortable with this, you can wait. Show. Okay, so may I ask Lina to share the screen? And because
Okay, so Dr. Kellen, I'm confused. I tried to start on Photon and I copied all the files and then I
do not worry, we will figure it out. Please share
Okay.
screen. We will fix
Okay.
it in a.
I moved now to NERDS, but I don't know what model to use, so I'm confused.
Okay, so if you are, can you open second window and show your, okay, LS?
Okay.
No, if, are you telling that on Photon you have all files ready? Or no, you're not sure?
Yes, yes.
Do not exit, just open another window. Make TOP here, just to save time. I think those commands that I see, those are from Raju, who's he stopped visiting group meetings but continues to use the resources. Okay.
This is right.
So, okay, more key points. Okay, tilde slash bin, just run wasp.
Slash.
Oh, just a second before you do it. Before you do it, can you please erase everything? Backspace, backspace.
Yeah.
PWD. Yes, to learn where you are. PWD. P lowercase.
Yes.
WD, and copy this the whole directory. Okay. Yes. Now run wasp tilde slash bin wasp, not apostrophe but tilde. Wavy line. Wave line.
Now slash.
Slash wasp, lowercase.
Okay.
Lowercase wasp. It will not work. Backspace. Wasp with lowercase.
Okay.
And not underscore but dash, like minus sign.
Where here?
Yes, dash.
Yeah. Okay.
Not slash, dash, minus.
Okay.
Enter. Okay. And we let it go and compute. And now let's go to NERSC. Maybe it will do the job quicker. So go to your directory and to the lab 11, CD space winner. Enter.
Okay, I think I didn't.
Okay.
Okay.
CD lab 11. And now type rsync rsync. It originates from the space, from the word synchronize, minus AV, lowercase a, lowercase v, space. Now type Q at photon. No. First we need to type, go to the beginning of this thing and type the name of the user and name of the server.
Oh, okay.
NDSU. No, duck.
That is it.
You now column 2 dots. Oh, yes. Now paste the path. Paste the path. Slash star, which means all files. Space. Period. Enter. Type the password, please. And now let's check quickly to the other window how the photon is doing. In the other tab. Yeah, it is not yet done. So let's return back to NERSC. Maybe it will set up competition, whoever is quicker. CP, we need to copy one more file. CP wavy line, tilde, slash bin, slash uppercase Q, U, E.
What?
Now letter U, uppercase U, uppercase E.
E, Q, E.
Slash debug, DEBUG, .sh, space, not SCH, but SH without C. Abbreviates from shell, space, period. Enter. VI debug.sh, space, debug.sh, enter. And now we need to modify last line. Now go to the right. Letters GAM, GAM, needs to be replaced to STD for standard. Yes. And now escape, column WQ. Okay. And now S batch, SBA.
Yeah, yes, batch.
Not butch, but batch. Yes. S batch. BA.
B.
BA. T.
Yeah.
CH space debug.sh. Space debug.sh. Enter. And now to monitor, yes, SQS. First type SQS. S. US.
Okay.
Vertical line, grep.
And enter, right?
Space and then upper.
Oh no. Oh, sorry, it's not.
Yeah, space and then paste this name, number of the
number.
So it's pending. Maybe photon will win in this case. Let's go to photon. No, it didn't win yet. Let's go back. Try do arrow up. Go to the beginning of the line. Do not erase, just arrow left. Type watch, W-A-T. Watch, yes. Apostrophe. Just apostrophe. Quotation. And then go to the end of the line. Yeah, good. And go to the end of the line and make another apostrophe. Yeah, enter. So right now it is pending, and I probably will go to visit another online attendee, but this, as soon as you go to the queue, it will show R, and then it will complete the job very quickly.
Okay, so I will wait NERSC and photon to complete.
Yeah, and as soon as either one of them is done, let me know.
Okay, thank you.
Yeah,
Just
yeah,
sharing now.
I think it is good. Sarah, would you like to share screen?
Yes, sure.
Stephen, how things are going at your side? Is it complete? Did NERSC complete?
Okay, I just copied the files and run the VASP in the photon. So
Okay.
here are the files.
Okay. Now let's check if this cheat sheet is available on Photon. Let's type more space tilde slash bin slash advice uppercase advice period dispersion DI, and now hit the tab button. It should automatically hit it once again to see options. Hit tab button. Dispersion version 10 .v10 .v10 enter. Okay. So let's copy the second non-zero line, grab K point.
This
Yeah.
one.
Yeah, copy this one and paste. Enter. More space KK. Enter. No, not good. Maybe something is wrong. Do more space K points. More space K points, uppercase. K points. Enter. It's a wrong calculation. Let's do VI K points. VI space K points. K point, yes, enter. And now let's edit the first line, not first, line number 4, record number 1. So replace 1 to 16. Escape colon WQ and rerun VASP. So on Photon, it will take some time. You can either just wait until it completes or open directory on NERSC for this job and copy input files and try to run job there, whatever goes quicker. So
I'm not familiar with the NERSC. I haven't tried to log in the NERSC.
okay.
Maybe I can stop sharing and take a look at Kia's screen and then
Yes.
to me.
Yeah. Yep. Okay.
Thank you so much.
Oh, not a problem. Kia, would you like to share screen?
Yes, just one.
Thank you. And while Kay is sharing screen, question to Sarah. Does your group has a VASP license to use it on CCAST?
No, no, it doesn't.
No,
Okay. But you run other codes on CCAST, right? So if I include you into the VASP license, you will be able to run it on CCAST.
Professor.
Okay, Kay, you are on the Photon. Okay.
I already copy the, but the thing is, it's warning and error, so I stop here.
No, do not. It's warning. Warning is not an error. It's like if I travel a public transportation and it is overloaded with people, someone step on my toy, and I will start screaming and telling, why did you do it? If the person doesn't apologize, but it doesn't mean that I exit the bus and stop driving, stop traveling.
It didn't work.
Was just complaining. No, do not worry. It's things will work. It just wants to scream at us a little bit, but it will do its work.
So should I run this one here?
So I suggest, yes, you just wait. We will do competition between Photon and NERSC. So before you rerun VASP, would you please do PWD?
PWD, okay.
Yes, PWD.
PWD, yeah.
And copy this string so that we can use it on NERSC.
Control-C.
Copy, and now run. Oh, before you run VASP, can you also please type more K points? I just want to make sure that you're using points. Enter. Good. Now please run VASP. Enter. Okay, and it will take some time. We can either wait or let's go into the
Lola
app where you are logged into NERSC and try. Maybe it will go quicker.
Yeah, my job has finished, Professor, and the Photon.
Okay, that's good. That's good. So, which means Photon is not so bad.
Yeah, me too. It finished. And
okay.
Something wrong with NERSC. I don't know what.
Okay. So then if you want, you can try to copy files to NERSC and run this job there, or you can just patiently wait, whatever is comfortable.
Okay, I'm waiting for.
Okay, I know several people are tired, exhausted, and angry, either on me or on NERSC.
Okay.
So then please stop sharing, and I will visit with Vola. Vola, would you like to share screen?
Yeah.
Oh, it looks like you're computing orbitals. Okay, let's go to the end of this thing, of this screen.
The end,
just scroll,
like the
yeah,
top?
scroll down, scroll to the last, to the no, not up, scroll down. Just do Control C. We do not need this bands. So please type more space in car. Enter.
Oh.
Okay. This is a specific in-car to generate orbitals, which we do not need right now. So let's do MV space. We will, instead of removing, we will just rename to different name, MV.
You say MD?
Not MD, MV. Like, yes, space, in-car, space, in-car, repeat the word, in-car, dash, PC for partial charge. Enter. Enter. Now CP, wavy line, tilde, slash, not periods, slash, bin, bin, not in, but bin, slash, in car, no, uppercase in car, dash, no, minus, dash, minus, G, letter G, like, and now tab, hit tab to see, yeah, period, enter, period, enter, arrow up, divide, slash, and type in car, just in car without any in car, enter. Now VI space in car. Okay, it is a good in car. You can escape double column WQ exit. It's a good in car for single point. Now let's do more space K points. More space K points. Enter. Good. And now let's rerun WASP. Tilde slash bin. Slash WASP minus photon. Enter. Okay, so if it looks too long, you can try doing the same job on NERSC, but other class attendees told that it will be quite quick. So probably I will make another round and return to you when the job is done. Is it okay?
Yeah.
Okay, then please stop sharing. And yes, thank you, Kay. I see your message. And let's go, Lina. Will you share screen?
Yeah, sure.
So
So I thought we need to apply this command now.
backspace.
Backspace, okay.
V version 10.
Okay.
0 space and erase these things about titanium. This specific things about titanium are on available on NERSC, and I didn't copy it to the bottom. Enter. Okay, now let's copy second non-zero line. This grab K point. Second from the top of the file. No, not from the bottom, from the top.
Oh, here.
Yeah, grab K point, copy this, grab K point, yeah, copy this line. Copy and paste. And now do more space KK. Enter. Okay, very good. Now let's copy next line in the cheat sheet.
Next line here. This?
Yeah. Copy, paste,
Oh,
and
what happened?
now let's go arrow left. Just go and replace number 1 into the number 32.
This?
Yeah, replace it with 32. Now arrow right, replace out car, just remove number 1. Yes. Now arrow right to the number K1 and replace it to K32. K32. Enter. Now more space K32. Enter. Let type more out car. More space out car. Enter. And just hit period several times. Just hit period many times. Do not wait, go through. I'll tell you when to stop.
Yeah.
Okay. So stop. And
Done.
find one of the lines for homo with 32 and copy. Copy starting from the very beginning of line, literal beginning, not from number 30. No. Line,
wow.
same line where you were.
Okay.
Start from the beginning of the line. Include the spaces. Include spaces before.
Okay, like that.
Stop. No, do not include -6. Error. A little more. Few space. Include few spaces. Okay. Yeah. Copy. Now arrow up. Arrow up. Arrow up. Now.
Yeah.
Yes. And go back to this 30. Erase everything between quotation and paste whatever you copied from the file. You need to practice
yes.
arrow left. Yes. And now backspace, paste, backspace, and paste. Enter. More space K32. Very interesting. Very interesting. Can you give me, well, let's try once again. If it doesn't work, I will just go to your directory. Remove a couple of spaces before 32. Not after, before.
Before?
Yeah, before 32. Do we do it? Enter. More K32.
Okay.
Good. Okay. So why we include the spaces? Because the number 32 may happen randomly in some other combination of numbers. And with spaces, it will be unique. Now arrow up, and arrow down. Replace 32 to 33. 3.
And here?
Yeah, also 33. Enter. More K33. Okay, good. Now let's look through this cheat sheet once again. Do arrow up until it pops up. Or or scroll just to see it.
Where?
Maybe it's better to do arrow up and show it once again.
Okay, so we need
just go
command.
You see, it's too many things, too far to scroll.
Here, right?
Yes. So select the line with PR, the one before GNU plot. PR.
PR. Okay.
Copy this line, and now paste. Paste, but do not hit enter. It's okay. Arrow up. Okay. Arrow up, and now arrow left. Delete. No, delete. You need only. You have only 2K points. Delete. Delete. Stop. And now replace K1 with K32. And K2 with K33. Enter.
One space. Okay.
Yeah, enter. More space KKEE.
EE?
Yes, the file that you just created. Okay, good. Now let's look into the cheat sheet once again.
Okay.
So, and copy paste this GNU plot line. Copy paste.
No.
You can hit enter, but it may not work. Okay.
Oh,
Now, do not worry. Do not worry. Delete, erase several symbols. Delete, delete, delete. And now hit tabular. Tab button.
What to hit?
Tab. The tabular.
Tab. Okay. Tab.
Yes. So it should have, yes. And now type HOLU, Honolulu. Enter. No errors. Now type ls-lt. And now type PS to PDF. WR space, and then the name of this PostScript file, band underscore Honolulu. Band underscore Honolulu. Dot PS. Enter. Okay. And ls-lt. So you see there is a PDF file. Let's find it on the left panel.
That's nice.
But can you share with the rest of us?
Okay. I'm just sharing.
Just stop sharing and start sharing the whole.
Okay.
Okay. So it works, right?
Yeah. Thanks.
So at least we have secured. Your presentation is secured now. I finally understood why we are processing a little slower than in previous years. In previous years, when everyone was in class, I was visiting just a couple of those who finished first, and then asking those who already passed control to help to those who didn't. And then it was like speed up 3 times. A little too late, because next thing we will do projects, but Boston and Lena, you can in the chat line offer help to the rest if someone has questions.
Yeah. Sure.
Assist. Okay.
Okay. Yeah, I'll stop sharing now.
Yep. Thank you.
Yeah. Thanks, Doctor.
Oh, my pleasure. Sarah, would you please share screen?
Sure.
And please talk to each other. Ask maybe private questions. I'll keep doing what I was doing, but just in case. So you have this KK, and now we need to generate this K32 and K33, right?
Yes.
Do you have this? Can you open the cheat sheet? Yes, enter. So copy the next line after, yes, this grep 1, copy this line, copy and paste. And let's modify it. So replace 1, yeah, remove 1 here. No, you have just out car. Replace number 1 here with 32. And based on experience of Lena, remove a couple of spaces before 32. Just do it. And maybe after 32 also erase a couple of spaces. Do it. And now go to the end of the line and make the file name K32. Enter. More K32. Enter. Good. Arrow up. And then replace 32 to 33 here and there. there, hit enter, more K33. There are more standard codes to extract this energy, this information from VASP and do two-dimensional, three-dimensional dispersions. But if you will run these codes, we will not have hands-on about the internal structure of the file. So it's a little bit painful, but then you will be very independent on other pieces of software. Now, Sarah, in the cheat sheet, please copy the line with that starts with PR. Third from the bottom, yes, PR. Paste. And now, yeah, remove. Stop. Now replace K1 to K32. And, yeah. Enter. More space KKEE. Okay. Now it's good. And now copy paste the next line in the cheat sheet. Yes. Yes. Paste, but do not hit enter. Erase V10. Do it. And now type, do it once. And now type HOLU. Boston, if you're not speaking, you may mute the microphone, I think, because we
Oh, I'm sorry.
That's fine. Enter. ls minus OT. Now PS to PDF WR. And then the name of this file. Paste. Enter. And now let's find on the left panel. Yeah, on the left panel, update. Please share the whole window. Stop sharing and start sharing for the whole display so that we can see it. Okay, perfect.
Thank you.
Yeah, very good.
Thank you so much.
Yeah, you can stop sharing. Kea, would you like to share your screen?
Of course. Just 1 minute. 1 minute. Okay. Yep. Oh. This one. So job is done. I need to copy this one, right? No, not here, from there. I need to do from this section.
Oh, you stop. You
Okay.
can, if you already copied this, you have this cheat sheet in your notepad. Can you go to your previous window? The window that you were just showing. Yes, notepad.
Yes.
There is a next line. Grab K point out car.
Yes.
Can you copy this line?
Copy. Okay.
Copy and then go to the command line and paste.
But I didn't do anything. Just I use this command.
Yeah, yes. Now just paste. Enter.
Okay.
More space KK.
Space KK. KK. Enter.
Yes. Okay, good. Now let's go back to your cheat sheet in your notepad. Copy this line. Copy. Go paste. And yeah, enter. More space K32. Enter. Very good. Now let's go back to your cheat sheet. Copy this one. Paste. more space K33. Very good. Now let's go back to your, now, yeah, this command.
From this.
Yes.
So Professor, why don't I need to do the whole procedure?
You do the whole procedure.
When?
Enter. More space KKEE.
Okay, just a minute. More.
We just checking that results are good on each step.
Okay.
Enter.
Okay.
Yeah, good. Now let's go back to this list.
This
Yeah,
nine,
copy.
copy,
Paste.
enter.
Mhm.
Then this line.
Yes. Paste.
Enter.
No. PS.
Oh,
You can type it. PS2
PS2 PDF
WR space.
space.
Band BA
That name, right?
and sheet tab. It should continue automatically. Tab. Yeah.
Oh, okay.
Enter. And now let's look in the left panel, update, and double click on this home element.
Yep.
Okay, very good. It works. Okay, thank you. You can stop sharing, and Lola, please consider to share screen.
Okay, stop share.
Okay. Hit enter. Very good. Now let's copy the first line after this. Yeah, the grep one. The next line from the cheat sheet.
Okay.
No. Next after which
This
you use.
one?
No. Next. Lower. Next. Yeah, this one.
Mhm.
Copy. Paste. And then arrow left. Arrow left several times. You need to replace the number 1 to number 32. Replace 1 to 32 and erase couple of spaces before 32 and erase couple of spaces. Do it? No. Keep put at least 2 spaces after. Space. Now go to the front before 32. Do it. Enough. Maybe 1 more space. Okay. Now arrow right several times. Remove number 1 at the end of out car so that it will be just generic out car. Yep. Arrow right, keep going to the end of the line. And replace K1 to K32. Enter. More K32. Space K32. Enter. Okay, very good. Arrow up 2 times. Arrow up. Now replace 32 to 33 here and at the beginning. Enter. Okay, more space K33. Enter. Good. Now in the cheat sheet, copy the line that you still see, this PR minus TMJ. Yeah, copy and paste, but do not hit enter. Paste. Now arrow left several times. Start erasing. Remove this K9, K8. Remove. Do it. Do it. Stop. Replace K2 to K33. Replace K1 to K32. Enter. More space KKEE. Enter. Very good. And now let's look on this cheat sheet once again. Yeah, copy this line. Yes, the new plot. Copy, paste. Erase V10, delete, and type HOLU. Delete V. No, delete the letter V as well, and hit enter. Now type ls minus ot, ls space minus ot, enter. Oh, arrow up. No, arrow ls minus ot, vertical line space head. No, not slash, but vertical line. Yeah, head. Enter. You see there is this band homo lumo. Now type ps2 pdf wr space, and then name of this file. Yes. Click, paste, enter. Arrow up 2 times. Enter. So there is a PDF file. Now let's navigate to. Thank you, Kia. I see your comment. So all of us go to the left panel.
You what? Okay.
Use left panel. Yes. Let's navigate to your directory. And if anyone has a hint how to, maybe you need to click on this green circle to reconnect SSH browser. Yeah. Now let's navigate. Yeah. Yes. 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 Periodic. And yeah, open this one. And probably you need to share. You need to share the whole display so that you can see. Oh yes, and scroll down. Yes. So it is changing a little bit. Maybe if the geometry was different, then the slope of these curves is different, and it's okay for now. But later on, one can get different dispersion depending on chemical composition and depending on geometry. Okay, Kia, thank you. You can stop sharing.
Sorry, one question.
Please.
So I see that mine is a bit different. Is it as a result of, say, the geometry of?
Yes, it is a result of geometry. If your size of the cell is different, or the optimization was not ideal. So for now it is okay. And when we will be doing projects, I will carefully check with everyone that geometry is optimized. Optimization of geometry is the serious part of the job, but it takes most of the time. I didn't want to bother you with this at earlier points. Okay, any other questions? Okay, stop sharing. I'm going to go forward with anions, cations. Maybe I'll skip excited to the very end and then do singlets and triplets. Boston, did you succeed in? No? Okay. Probably since we have only 20 minutes left, I will do as much as I can, and we leave questions and answers session to like free time of each of you, so that I use this time with maximal efficiency. Whew. So you like photon more than NERSC, right? I think most of you used photon.
Yeah. Oh, sorry, you forgot to share your screen.
Oh, thank you, thank you. I could go too far with it. So copy both. What would I do? I did periodic scar, and I copied into basically into each line. Line for the double triple. I just want to I want to use the same model in different configurations. And now I also will copy the port car into each of these files. Next, neutral. Next, tablet. Next, triplet. Car. Okay, what else do I need? Oscar put key points. No, key points will be, I do not need the 16, I'll copy it from the template. And the in car, no, I'll do it from scratch each time. So going to the first one, neutral. Neutral. So it will be trivial calculation that I may copy from elsewhere, but I better use it, do it from scratch. So I copy the generic key points and generic in car into here. GM here is in car. In car. So, and now I can do quickly bin last.
Professor, can you also copy paste that comments to the chat, please?
I can, but I think it is all of them are trivial. Huh? Why it is so? I did something wrong. More just. Okay. Once again, I'll make sure that things are okay. Now it's working. So the only non-trivial, I can copy all commands, but they are. So this one was maybe a little surprising, although we used it before. Enter, and the location of key points. I don't know if you need it. You probably have it. And location of yeah, that's it. That's it. And then I was just copying it systematically. So let's see how it goes. So those things that pop up to the screen are the optimization cycles in the loop that we did on Tuesday, right? So it updates the set of constant orbitals, it constructs density, recomputes the energy, and the energy is stored here. If you see as we go through, it gets lower and lower. And since I requested 0 NSW, it doesn't do optimization. Now, the thing that I need, rep number of electrons in the outcar. We probably were doing this little experiment before. So number of electrons. And it gives that here in this model, number of electrons is 64. So I can copy this record at VI in car and put somewhere here, copy this command. So if I look into the outcar right now and go to the list of orbitals, I can notice for my record what are the properties, so band gap and other things, and I even can copy the CP outcar 1. And now I do have new thing in the in-car, new line. This line is trivial. It doesn't teach us anything. It just states number of electrons. And I can rerun this once again. And I expect that results must be absolutely the same because it is a trivial thing. And it should get conversion much quicker because it starts from where we left off. So 3 iterations. And last 2 columns here show the characterized forces between atoms. So the convergence here is, the numbers are much bigger. So electronic conversions to 10⁻⁵ and ionic forces a little bigger. So if I look through the in-car once again, it is a new in-car. So the numbers here, the structure, electronic structure should be same. So HOMO is 32, LUMO 33, and the gap is same as was before. Now, I'm copying everything from here into the directory anion. Copy, chat line, paste. Now I am going to the directory anion. VI in car. And now anion means the system is reduced. It has additional electrons. And I change number 64 into number 66. So it double anion. I place 2 additional electrons. And escape, WQ. So just artificially modify number of electrons. And if I fear that my memory doesn't serve me well, or if I want to share it with any of my colleagues, I can make this comment. It is anion. Now I want to run VASP once again. So okay, I see it tries to scare me with errors, but I do not fear. It's very hard to satisfy VASP. It will complain all the time.
Okay, Professor.
And now we get more steps, because the electronic structure, when we add additional electrons, the total density changes, potential changes, and all electronic structure changes. Although, according to this Koopman theorem, it should be just putting more electrons onto LUMO. It is a little bit more complicated. These orbitals interact, and I remember that, when you were presenting last time, you were telling about that there were homeworks about ionization and affinity, right? So it was approximate calculation. If you need to be exact, one does need to practice to actually modify number of electrons and to explore how the total energy responds to change of number of electrons. So what we are doing right now corresponds to electron affinity. The response of the system to addition of additional electrons. And the anions, since LUMOS are closer to free electron structure, the structures with in anionic form are often less stable than neutral or cationic, and therefore some procedure for optimization, even an electronic optimization, and later on also nuclear optimization, can come into frustration and both use much more steps. To save time, I'm not doing geometry optimization, but it will be different geometry. It would go through. So now let me look through the outcar. More outcar, and I'm just scrolling to the place where we have this orbitals. So we see that the orbital 32, which was HOMO, is still occupied, and the orbital 33, which was empty, is also occupied. And we have occupation distributed between 33 and 34 because they are almost degenerate. So the VASP tries to play Fermi distribution on us. And it is important when there is a degeneracy between levels, when especially for metals or situations like this. So what I am interested to do is to check how the density of states will look for this situation and compare it for density of states for a neutron. Copy. I states paste their list of orbitals. Press DOS norm. Number of states 22. So instead of grabbing, I just copy pasted this segment. Minimal energy, maximal energy. I just take it from the list. So minimal maybe from -7 to +1. -7
Oh,
+1.
excuse me, Professor, shouldn't the state file have the 40 lines instead of 22? Why?
Thank you for the good eyes, Sarah. The procedure for developing density of states is only the way to analyze the data. It is not a scientific procedure. It is not a part of DFT. And it is a free balls, in good sense, decision of a researcher how many orbitals to include. You can make density of states with only 2 orbitals, home and home. You'll be not very smart, but it is possible. And when we play with small models, it is just easy not to think how many orbitals to include and include all of them. But as soon as we go to the projects where number of orbitals will be like 2000, it will be, and a lot of these orbitals will be very deep in the X-ray range with very small energy, or very far in the already dissociation, dissociation limit. So we'll just keep only orbitals in the vicinity of the gap. And the procedure for making density of states works equally well. So it's only a tool, and no one can dictate you how do you use your tool. You risk only visual appealing of your results.
Thank you.
Dr. Kivin?
Yes?
But if you are, okay, first of all, I don't know if I missed it. I don't know if I missed it, but did you, when you did VI states, did you alter anything to 22? Because I'm wondering how WC states is giving us 22.
So I just decided to take several states near the HOMO and LUMO. So I can use like maybe from 20 to 40 or from like 25 to 40. It doesn't matter. I am interested only in the range near the gap. And basically everything except this vicinity of the gap is a garbage. So those are garbage and those are garbage. If I want to be very precise, I can add this information, but it doesn't teach me any physics or chemistry. Make sense?
Yeah, but so
before I was suggesting you to use all to avoid this discussion and make all calculations quicker and more, how to say, unambiguous. But you are free to use as many orbitals as you want. And especially for small systems, I just wanted to save a couple of minutes on, instead of typing this grep command, just copy paste the orbitals directly from our card. Make sense?
Yeah, but what I'm trying to confirm is, does the 22 in any way exclude unoccupied? Like, are we sure that the 22 includes both occupied and unoccupied orbitals? Because like
yes, the orbitals that we include into the to plot density of states should include both occupied and unoccupied.
So how
we should select several we should identify gap and then select several states below gap and several states above gap.
Okay.
Okay.
Yeah.
Now I need to learn what is Fermi energy. Fermi minus 1 something. Go here and paste. Now alpha plus beta. I scroll up. Copy this number. Copy and paste. Then type 0.005. 1, number of atoms 12, number of electrons 66, gap 3. DOS is written. What do? GNU float bin GNU prog DOS. And then I want to look on this file. I just want to remove this both notations. So what I see in this image. So originally, typically, we have occupied orbitals in the valence band and unoccupied in the conduction band. And in the anion, we have additional population in the conduction band. So it's one observation. And another observation that all bands moved from -7 and -3 by about 2 electron volts up. Right? Another thing that Fermi energy, it was in the mid gap before, something like -4. Now it is where we have the transition from occupied to unoccupied. Now Fermi energy is about -1. Which means energy of this electron is not very high, and if it is placed, if this reduced model is placed near oxidizer, it will be very happy to donate this electron to someone, or these 2 electrons. So these electrons are metastable and they are easy to withdraw. I'm skipping to draw orbitals, but we remember that frontier of the conduction band were located on the titanium. Okay, now I'm going to follow the same pattern and do cation. So I see some comment. How to calculate the, and I was showing. What do you mean how to calculate that? I just changed one line in the in-car. More in-car. Huh? I think I'm sharing more in-car. So to standard in-car, I added an additional line where I modify the number of electrons.
Excuse me, Professor, is it important to put this number of electrons in the in-car file, for example, in line 3 or line 4? Is it important, or wherever we put it, it works? Because I put it in the first line.
Oh, where? Okay, I've got your question. So you are not putting under doubt necessity of this line. You are checking what is the position of this line in the file.
Yes, because I put it in the first line of the in-car file. So I thought maybe
it doesn't matter.
Oh, okay.
Did you watch Star Wars movies? Star Wars movie in English? Did you? So how the Master Yoda is speaking? So he inverts order of the words, right? Mm-hmm. So if you invert order of commands in the VASP, it will understand you.
Okay. Smart software.
Master Yoda.
Good.
But if you use the same command twice, if you in the first line you tell nelect 66 and in the last line 64, it will use the last one. Oh. Like if the human is unsure what to use, then WASP tries to avoid ambiguity and use the last word as the most correct one. Okay, so I'm going to do cation. So I just copy everything from anion to cation. And I can copy this command if you like to, but I don't think it is something smart you can naturally do. Now I am going myself to the cation directory. cd cation vi incar. And now in the incar, my reference value was 64 for neutral. But now I want to do cation. I withdraw 2 electrons and do 62. This is cation 2+. Copy. Chat line, paste. Now I do escape WQ and run WASP once over again. WASP. So it complains again, but I don't care. And you see, originally the energy changes drastically. It starts even from the positive values, which means in the first guess, it thinks it is very unstable, but then it goes to negative values and then tries to stabilize and optimize. The first line is the temporarily guess of energy at a certain step. And then the column number 4 is difference between 2 previous values. So in some sense, this 4th column is a criterion to stop. So when this DE will come to 10 to the minus 4th, it will stop. And in the incar, remember from the Tuesday meeting, there is a tolerance limit when to stop. This tolerance limit is there is a keyword if you inspect the content of the incar. Yeah, here, energy difference. I manually set it to 10 to the minus 4, but if you want to be more precise, you can add a couple of zeros. If you want to converge quicker, you can make it less. But just be aware that if you reduce precision, the results can be crazy. And Gaussian is not allowing such dirty tricks. It has some limits of precision predetermined because they want to be responsible for quality of their results. And WASP, instead of promising quality of results, it's promising stability of the code. So even if the model is something crazy that may, it will still converge and go forward for some transition states that are metastable. Okay, let's go see. Okay, it is done while we were speaking. So let me look through the more outcar, and I scroll to the area where orbitals are stored. And now the orbital 33 is back empty, and then orbital 32 and 31 and 30, both are, or all 3 are underoccupied. So because there is a degeneracy in this state, it's like a fraction of electron is withdrawn from each of the orbitals. But we definitely see that the top of the valence band is underoccupied, and we see that Fermi energy is shifted way down. So I want to visualize this list of orbitals, and we'll do the same procedure that was surprising, inducing some questions. So I just copy some number of orbitals. Okay, this much. Copy. Then VI states, and I want to delete everything I had before. Insert, paste. Paste. Okay. Escape. Q. WC states. So 19 lines in the file, and now I'm going to practice this dress DOS code. So number of states 19, minimal and maximal energy. I will show whatever is at the end of maybe from -12 to -5. 5. I should start over because this code is not forgiving for typos. Number of states 19. 19 minus 12 minus 5. And now I will scroll and find Fermi energy -10. So it's drastically different from anion. And this alpha plus beta parameter. Width of line 0.05. Number of atoms 12. Number of electrons now it is 62. Gap 3. And now let's convert this. So cation, those. So you see that bottom of the conduction band is very empty. The top of the valence band is under occupied. So this lack of electron, this under occupation of the band, means that in this configuration, the model is a strong oxidizer. So as soon it will be brought in a contact with any other chemical, it will be aggressively give me back my electrons. So if you have this titanium dioxide nanowire anion and cation configurations brought together, it will immediately balance electron. The one that has more will donate it to the one which is less. And such electron transfer between reducing and oxidizing agent is some modifications is a like key process in most chemical and physical processes. Like photovoltaics is example, for the catalysis is example. Many reactions go on this basis. Okay, so I will we are over the time, but I'll skip excited states. They are quite easy, but just will be a little lengthy. But I'll definitely start the triplets. It's a minimum. Yes.
Oh, excuse me, Professor. Can you just orally explain how to, for example, edit the in-car file for the excited state? Also, just orally say something, because
Yes.
I'm going to present it. This is my
okay. There should be the keyword Fermi weight. In the in-car. And this keyword Fermi weight, it should be very long line, telling like 1, 1, 1, 1, 1, 1, 1 for so many orbitals which are occupied, and 0, 0, 0, 0 for so many orbitals are unoccupied. So if I do such command, it will change nothing. It will be trivial thing. But if I manually change the population and put here 0 and here 1, it will mean that I have promoted electron from occupied to unoccupied. So I manually modify occupation of orbitals. Make sense? And just right now, I already holding you longer than needed, and I want to finish it as soon as possible. So triplet is minimal thing that we cannot skip. And later on, please remind me, I will send the templates both to presenter and to the whole class. It's quite easy, you can pick it up personally, but for triplets, it's like minimal basis that we need to see and discuss now. Sarah, do you allow me to go forward?
Yes, thank you.
Okay, thank you. Yeah, okay, I will show at least triplet, and then if time allows, I'll do more. So I'm going to neutral, okay. And now I'm going to copy everything from neutral to triplet. Now I go into triplet, and I will EI in car. I don't know if I need to copy the silly commands. I can do, but it will be only garbaging our chat line. Paste. And please remind me if you want me to copy the whole string of the command that we did, as someone suggested on one of the previous labs. So,
Me. I suggest. Okay. Yeah, it's good because if someone want to do this kind of things, later,
okay, yeah, yes, we'll
be helpful
do.
for us.
We'll do. Just let me finish at least this triplet calculation, and then we'll wrap up. And I apologize for it takes longer time. I know that you have plans for the evening. So for number of electrons, right now I can percent it out, but what I need for triplet, I need same as I4, I spin equals 2. And I can also put n up down equals, I'll do, if I put 0, it will change nothing. It will be the same as we did without spin. And
0
probably
that one is singlet, right?
yes, it will be singlet. So maybe make directory singlet, copy everything there.
And professor, if there there is a command like nub down, NUPDOWN. If you
Yes.
use there, yeah, that one, then that one is doublet, it's double. And if you use there 2 plus, I guess 2 plus means that one is triplet. Am I right?
Yes, you are correct. So here it will be triplet, and I'll put 2. So I spin means we will use spin components, and up down means that there are 2 more spins in alpha than in beta. And the rest is the same. So now I just run VASP once again. So by now you are already experienced in the K points in the moment of dispersion. And you noticed that when you do dispersion, it looks like we are doing calculation for systems that is 8 times bigger, or 8 independent calculations, each of which has a different set of orbitals. When we are doing spin polarized calculation, in some sense, it is, remember in Gaussian, we had alpha orbitals and beta orbitals. So it will look like 2 subsystems, one for alpha electrons, another for beta electrons. Therefore, this NCG command, it approximately relates to a number of orbitals. It's dynamic thing. Number of orbitals will be different, but we see it is twice as bigger compared to our previous run. If we scroll up. Yeah, here it is about 100 when we did different configurations for singlets, right? And now it is about 200. So it uses twice larger number of like bases, twice number because it is separate for alpha and beta. And we expect to have 2 sets of orbitals, and to the objective results are just list of orbital energies. But if you want to visualize and interpret, we need to visualize. We need to convert it into continuous lines. And then I will convert those into like states up and states down for alpha electron and beta electrons, and then plot density of states for alpha electrons protruding up and beta electrons protruding down. So while it is calculating why those triplet states are needed. If some of you are dealing with catalysts, metal-organic complexes, then they often come into, or magnetic materials, they often come, transition metals in them are in open shell configurations with unpaired spins. So there it is just natural language to describe magnetic materials and transition metals. But even if you deal with fully organic hydrocarbons, something that composed of carbon, oxygen, nitrogen, sometimes total energy of the triplet configuration is lower than energy of excitation. And the photo-excited molecule often prefers to convert into triplet state instead of radiate a photon back. And triplet states are typically dark. So the inclusion of triplet states into configuration can rationalize why certain molecule is dark, why it doesn't emit. So at the end of this calculation, it gives total energy, and then there is an additional message, MAG equals 2. It doesn't mean that we all are magnificent in the class. It means it tells magnetization, right? So magnetization or a number of unpaired electrons. So it's same as n up down. But in some calculations, it comes to magnetization, to certain magnetization, even without specifying n up down at the beginning. Okay, let's look into the outcar. Closer to the end. So spin component 1, which means alpha. And we have orbitals with occupations, the occupations are 1 instead of 2, right? Scroll down. So, and for, remember, 32 was occupied, 33 was unoccupied. But here we do have 33 occupied, right? Now we have spin component 2. So there are two lists of orbitals. We scroll further, and then we do have, so 99 is as good as 1, but then 32 is empty. So it means we withdraw electron from beta, from spin down, and promote it to spin alpha. So depending on material, such configuration can be less favorable or more favorable than singlet state. And it has practical meaning if, for example, if one inspects ability of molecule to irradiate light. So I'm going to copy this thing. First list, copy, and VI states up. And then I will scroll here again for spin component 2. And I will also copy it. And I will open another file, VI states down. And now, if I do not trust my memory, I will look if I have some cheat sheet for this procedure. Maybe not, so I'll figure it out naturally. So this boost up. And let me double check number of states up. Number of states 22. Minimal energy, maximal energy. So we'll do from -9 to -1. Fermi energy. Copy from here. Bits of flame. Okay, LS minus T. So it creates file DOS up for alpha component. Now I do the same for states down. Press DOS down. Oh, I need to copy these commands to the chat line. Paste. Paste. Okay. Number of states 21. -9, -1. Fermi energy. This much. Alpha plus beta. This much. 1, 12, 64, 3. LS minus LT. So we have DOS up and DOS down. Now I need to find GNU what? Tilde bin GNU prog DOS, and it should be up down. Let me copy it into the chat line. Copy. So we have file dos updown.ps. And now we need to ps to pdf wr to convert it into the PDF. And then I can identify this file in the So there are several interesting observations. The majority of electrons are still in the valence band field. Majority of the orbitals in the conduction band are empty. But by this command n up down equals 2, is obtained by withdrawing one electron from beta component and adding one electron into alpha component. So we take electron from this area, blue area, and promoting it into this red area. So I really wanted to complete it today, and at least the presenter should practice it, and maybe I'll try to design homework this. I understand because of presentation I may delay it for maybe 2 weeks instead of 1. But this is a skill that we starting next week we will start practicing towards your projects. And those of you who will have any metals, any transitional metals in your projects may need this skill. Also, representation of the density of states in this so-called spin polarized DFT is an immediate assessment of magnetization. So the bigger number of unpaired electrons, the stronger response of the system to external magnetic field. So it is also a signature of magnetization. And the most interesting situation when you declare I spin equals 2, and you do not mandate any specific spin polarization. So if without explicit constraint to spin polarization, one is getting this difference in alpha and beta, it means that a system is naturally magnetic. Right now, we do not know whether, likely not, we need to compare total energies of this configuration. Whew. Done. Everyone is welcome to disconnect and depart. I'll stay here and answer any questions. And please remind me if I can contribute important things, like if you want me to send the list of commands to the email. Okay. No
Thank you,
need to
Dr.
say-
Kellen.
Yeah, thank you.
Okay. Have a good night, everyone. Bye.
Yeah, good night. Good night, Nina.
Oh, excuse me, Professor. Should we repeat this process for the downward spins also? Yes. You plot this density of states for the alpha spins. Am I right? Should we repeat again this process for the downward spins or beta? Beta?
I understand each word, but I'm a little slow in understanding what do you mean. So, are you asking something globally or technically?
So for this density of state plot, you use the GNU plot DOS up. So we should repeat this process again for the downward spins also, or no? I mean that
Okay.
we should have two the PDF file or two density.
No. Okay. Who? Now I understand you. So it's fully technical question. I was fearing that you put on doubt any of the principles, and that now I see you don't. So you see in the chat line, you do dress those for up and for down, right?
Yes.
Now, am I still sharing, right?
Yeah. Yes.
Okay. So after I practice this dress those up and down, I'm getting two files, those up and those down.
Yes. Yeah.
By their structure, they are the same as regular density of states normalized those norm as we had before for single. And now, if let me bring the command up. Let me just. And the content of this command is not a secret. You are always welcome to look inside and make copy and modify. Do not modify it in this binary directory because it is used by others, but you can copy it to your subdirectory or copy to your personal account. I'm not claiming authorship for these 4 lines of the code. So look what it does. So it looks for DOS up and it looks for DOS down. And it draws is 2 times up and 2 times down. So the line number 4 is actual line density of states, and line number 5 is occupation.
Yeah.
So let's look also on the down. Goes down. So you see it artificially, one artificially adds minuses to the intensity here. So if you look for those up, here column 4 has all values positive. And
Yeah.
for down, the code automatically just multiplies it by -1 for the benefit of visualization.
Yeah.
So the this script for plotting just merges both up and down density of states into one image.
I see.
Does it answer your question?
Sure. Thank you. And I have another question. Should we repeat this process for the doublet and singlet? This is for the triplet.
No, let's skip. Otherwise, it will be too much. And if I want to include practice of the skills into homework, but I worry that I do not want it to be too big. So if you add doublets, it will be bigger, and doublets are less important. To those of you who will deal with transition metals, I will personally help. But now we need to speed up and focus on projects as soon as possible, because we started semester a little quicker than previous years, but now we are a little longer. I miscounted days and miscounted holidays.
Yeah.
Because in previous years I was avoiding Fridays and Mondays, so that no holidays affect the class.
I see. So for me, for the presentation, for the third presentation, I should just explain the anion, cation, and the excited form and the triplet.
Yes.
It's enough?
Enough. If you want to add something, go ahead. So it's better to do less, but with higher quality and better comprehension. So in some sense, you will be teacher and instructor of the whole class. And I will not do the following, but if I want to assess quality of your presentation, I would give a quiz to the whole class based on the information you present. So based on how information is digested by attendees, gives assessment of your presentation.
Oh, thank you.
So you are given instructions, and if especially this subject, which was last before presentations, someone was too tired and not focused, right? So you will be the major source of wisdom on this subject for everyone in the class. And it is important that you practice it yourself and report if you see some errors or you want to prevent others to avoid errors. Okay, I see your question. You'll be the next to speak.
Yeah, sure. Thank you.
Sarah, is it clear? Your question is done?
Yeah. Thank you so much. Have a good night.
Oh, you too. Thank you. Okay, you very politely raised the hand. Thank you for following the protocols. Then I see it. Well, I did promise extra credit for you for this extra work, so that you feel happy. And on another hand, you will be able to catch Sarah if she tells something wrong, right? You'll be able to ask her, give her tough questions during her presentation.
No,
So additional quality control.
I have a question on my topic, not Sarah's one.
Okay. Let's quickly check if I should expect questions from Lola. Lola, are you planning to ask some specific questions?
Yeah, but it's pretty long.
Very long. Okay, then I'll talk to Kay and then to Lola. And yeah, please, Kay, please go ahead. I'm listening.
Professor, the thing is, let me. Okay, I can share my. Just. Why I'm not able to share? Oops. Okay. Shoot. I didn't start it. This on my previous for the Bhags. So, Professor, you already completed this part, right? Hello?
Yes, I'm looking.
Yeah.
Yes.
So I need to follow. I just need to follow the lab session.
Not relaxation, but the heating and molecular dynamics.
Heating and molecular dynamics. Okay.
Yeah. The stuff that we did a week ago on previous lab.
Yes. Heating, H and M. Okay. The lab, last lab, and this one for this.
Oh yes, I can show it right now. It's a very quick and simple thing.
Okay.
If you want, I can do it, and I think it will be really.
Yeah, then
really
that will be great for me. Stop share.
Yes, I just want to. Quickly record the
Lab session, yeah. The command of the full lab session.
yes, all commands. The second
Yeah.
lab 11. Yeah, I'll start sharing so that you don't feel bored, but I'll use maybe 30 seconds to send email to everyone. Attach web 11.
Professor, that two models still running. That one, they solved their problem. Then I submit the job again, and still it shows R.
R is good. Okay. So I promised to show tracking of the temperature. So copy, chat, paste. Now I can do remove what? What TT using 3 this line. So temperature.
I have a question. Like, is there any manual for the command? Because
Yes. Remember, I was sending a lot of materials in the
yes,
email.
yes. Yeah.
And one of these manuals is on this subject. It will
Okay.
be named something like tracking temperature.
Okay. That makes sense.
So this is tracking of temperature during heating process. So I set it up, set temperature to 1000, and then it drops down. Then I heat it again, it drops down. But if I repeat this process again and again, it approaches closer and closer to desired temperature. Now, if I do the same thing, if I go to the
Molecular dynamics.
yes, molecular dynamics. So I use so now if I do GNU plot once again.
Yeah. Oh.
So we see that in average temperature is near the desired value of 1000. But since the model is quite small, it fluctuates. So the total energy is expected to be constant, but temperature, which is kinetic energy, is fluctuating. So this test shows the quality of the thermodynamic modeling of the system. So if the system is big enough, then it should be as close to straight line as possible. It doesn't mean that the modeling that we done is wrong, but it means that maybe it's not as good to represent statistical average because fluctuations are substantial. And one can also, yes.
Professor, if I increase the temperature, then there that model will gives us an accurate result?
No. Y-axis is temperature in Kelvin. right?
Mm.
And it shows how stable the temperature is. So we wanted temperature to be constant, but because system is very small, it's not enough degrees of freedom. It has deviations from average value, and these deviations are called fluctuations.
Okay. Okay, Professor.
Let me show something. If you're curious, I'm not. It's not mandatory, but it could be interesting. So column 1,
Okay.
2, 3, 4. I'll just put several columns and then comment on them. What design?
T means temperature, E means energy, F means F
Free energy.
free energy. Okay.
Yes. So this total. Now you see this total energy is almost a constant. So you see this fluctuations of total energy. They are in the 6th digit. So we just magnify this stuff. And there will be another line. Yeah. So this number 7 is 7 and using 9. It's fine. Okay. So this could be interesting to Boston. And we'll add this TT using so this red, green, and blue, they are a little offset so that changes are not well seen. But the blue, which is in column 5, is the total energy. You see, it is quite straight.
Yes.
The red, which is column 7, is potential energy. And the green, which is kinetic energy. If you look on the green and red, they are in the opposite phases. When green goes up, the red goes down and opposite. But if one add together this red and green, one will get blue, which means summation of kinetic and potential is equal constant, right? So this analysis of kinetic and potential is more relevant if system is small. But if your model has more than 100 atoms, the average kinetic energy will be very close to constant. It means that 100 atoms is already a statistical system with fluctuations will be negligible. It's only for curiosity. You are not mandated to tell it. It's if you find it interesting, you can tell or just satisfy your curiosity.
Let's see, because I saw the last time just someone present the movie part, just someone present the first part for me every time, 3 things.
So for visual appealing, I would appreciate movies at most, and I think it will be more fun to observe.
Yeah, I will do that. It's okay.
And again, the addition to last homework about making movies, I didn't push about it, and not everyone in the class did it. So I do not have guaranteed records that all attendees of the class know how to make movies. So it's better if you teach everyone and and
Okay.
then we can use it in as a part of projects.
Yes. Yeah.
Any other questions?
No. Okay,
Okay.
Professor.
Yeah,
Bye.
thank you, Kia. Yeah, bye. Have a good night. And let
Good
me
night.
check with Lola.
Hi, Dr. K.
Hello.
So I was very lost in the last part of today's class. When you were plotting the cation and anion. First of all, you copied the cation and anion. I don't understand where you copied from.
Okay. Okay. Let me tell something, and maybe if you remove the question right away. So I'll just bring one of them as an example. So first, I did a neutral model, which is neither neutral, neither anion nor cation. Why I did this? Because I needed an evidence from computation for the number of electrons. Of course, I can make educated guess and look into periodic table, but when it is computed by computer, it's more reliable because sometimes it doesn't count some 4 electrons. So I did neutral model, and then it was used as a source of information of number of electrons. Then I did copy everything that I had in the directory for neutral model into a new directory for anion. Why? Because I am lazy, because it is the same model, because I do not want to copy files one by one, because it is the same model, and the only difference between cation and between neutral and anion was number of electrons. So I created new. Do you hear me?
Yes, I can hear you.
Okay, I think the lamp in the projector went out. But we can keep chatting. So I was copying because first, I do not want to run multiple jobs in the same directory. I want to keep clear system where the name of the directory prompts to me what I'm doing. Second, I wanted to minimize my effort as a person, just to copying everything with a star command is quicker. And then I went to new directory, modified the incar by changing the number of
Electrons.
Make sense?
So how did you build the neutral in the first place? I didn't see that. Like from the part where we plotted the momentum against what's that again? The band homolumo that we first plotted. Right after that, the command line I saw was the anion and cation. So at what point did you create the neutral, which you now used?
Okay, the neutral model is the same titanium dioxide nanowire which we used in previous 3 labs. So I just copied it from previous from lab 8, I think, when we were doing density of states.
So are you saying, because I know that like
so
after converting the band holu.ps
okay.
to the next line I saw was cp ... /cation. So I was wondering, where were you copying the cation from? Was it already created somewhere? But you're saying now that you used the new.
Let me look into this. Tell me when to stop.
Okay.
Oh, already here. Right. So I went to the photon.
Okay.
Here is the neutral. Okay.
Sorry, can you keep scrolling? Like I'm looking for.
No, I took.
Because here you've already opened the neutral
Yes,
folder.
it was running. So before this, last thing that I copied. So I took postcard from the lab 8.
So you created a new folder called neutral and then took postcard. Okay.
Does it answer your question?
Yes. So yeah, so you're saying after this was when you did the cation and anion. I must have
Okay.
missed.
Okay, so after I did this neutral, the most important thing was this grab number of electrons. So I learned how many electrons are there, and I inserted this line into the in-car. And then I ran the job once again, just as a little test. And after this, scroll. I just learned that nothing dramatic happened. Nothing dramatic happened, yes. Yeah, sure. And after that, I understood your question, and I'm going to the place where I copied from neutral to anion.
Okay.
Should be very, very close.
Yeah.
Yes. So I copied everything from neutral to anion.
Is that what this star does? It makes you copy
Star
files.
means all files in this directory.
In the left, the neutral goes to the
Yes.
anion.
So all files in the directory neutral are transferred to the directory anion. And then in the directory anion, it is not seen here, but I was editing in car, and I changed number of electrons from 64 to 66.
66.
And then I ran VASP
So,
again.
yeah, so I also wanted to ask, so I'm wondering, how do you know that it's supposed to be 2+? I mean, so in my head, I was thinking the anion part is okay, maybe oxygen is like 2-, but titanium is like 3+. So how
Okay.
do you know?
So there is an additional thing. If we use singlets, if we do not use iSpin command, then it will be very wrong to modify number of electrons by 1. We need to change it by 2, by 4, by 6. If you really
multiples of 2, is that what
if for chemical reasons, if you need to do 1+ or 1-, if you need to withdraw 1 electron, then it needs to be associated with this iSpin command, and then one needs to deal with spin polarized.
Okay, so what does iSpin do for you?
It allows separate treatment of spin up and spin down. So if we do not want to deal with spin, if we do not want to practice this command iSpin equals 2, which it's not a big deal, but it makes things a little bit more complicated. So if we do not want spin, then we change number of electrons by 2. We add or remove 2 electrons or multiples of 2. Otherwise, the computation will give some unreliable results.
So it doesn't have anything to do with charges of the.
No. It's not. It doesn't deal with chemistry. It deals with property of the DFT procedure. So if we do not, if I am lazy and I do not want to deal with spins, but I need to describe anions and cations, I change number of electrons by steps of 2, +2, +4, +6, -2, -4, -6. If by chemical reasons, by need of research, I need literally add or remove 1 electron, then I need to use a spin polarized model, this I spin equals 2.
Okay. So I see that for number of states for cation, you use 19. So my question is this like from is this capturing from number 1 to number 19 on the list of the states, or what does?
No. Number of orbitals that I used is completely voluntary. I just decided how many orbitals I need because I was in a rush, and if I use a little few more orbitals of US, it will not change how the density of states picture will look like. So the orbital number maybe 19 or 20 will contribute to this edge of very low energy, and the orbital number 40 will be here. And if I put more or less orbitals, they will not affect this gap area.
So you're saying it doesn't matter?
Yes.
Because you remember when I was asking the question about 22, what I was trying to understand was, is it like number 1 to number 22? Like, how do you decide to just pick one number, given the fact that even that 22 is like it's an occupied orbital? So I was wondering, are you picking for only occupied orbitals?
No, I was picking several occupied and several unoccupied. So I was identifying which orbital number corresponds to the gap. And then I was taking about +10 and -10 orbitals below and before and after. But there is a little freedom if in how you take number of orbitals.
Because I'm trying to think, like, imagine I mean you give an assignment now. How does my number of states, because when you ask for number of states, you're going to ask for minimum and maximum energy. How does the number of states I'm picking affect the minimum and maximum energy that I'm going to choose? I can't just choose random.
Okay. Yeah. I see your question. You are very logical. I like your questions. So let's go here, this example. So if I want to use only orbital number 20, and I want to skip orbital 90, right? Then I start my density of states from minimal energy of the orbital 20, -8.7. Then I do not need to include the range below, right? So I look what was my first and my last orbital in the range, and I use the numbers of the first and last orbitals as the range, where I start and where I end.
Okay, so if I was going to choose that -8 as my maximum energy, would my number of states be 20?
If you select -8.
Yeah, if I select -8 as the maximum energy, would the number of
yeah, you can, if you need starting from -8, then maybe you can start from orbital 23, because 22 and lower orbitals will have energy less than -8.
Okay. Okay. You were saying something about alpha and beta. I really did not understand that
Okay,
part.
yeah, thank you. I'll quickly show. So it was very close to the end. So when we used I spin equals 2, when we did the spin polarized thing, then outcar contains two spin components, spin component 1 and spin component 2.
Okay, so why do we have this spin component 1 and 2? Is it
So
because
just a second. So spin component is often referred to as alpha, and spin component 2 is often referred to as beta, only as a nomenclature. So please continue with the question.
because like normally when we try to run like this states, it doesn't show us spin component 1 or spin component 2, right? Like when we do it under plotting density of state, I don't think I've seen anything like spin component 1 and spin component 2.
So before we never used it because we didn't practice this command I spin equals 2. But as soon as we request this I spin equals 2, this red things will be spin component 1, and blue thing will be spin component 2.
So you're saying that, I mean, maybe I was lost, I wasn't paying attention. Like there's a part in the command line where you had to edit the I spin and the spin.
Yes, exactly. I added I spin equals 2 into the in-car. And as a result, we are getting the spin components.
Okay. So why is this density of state plotted this way? I don't really understand what I'm saying. The ones with the green line, purple line, I don't really understand.
This is needed for materials with unpaired spins.
With what?
Unpaired spins.
Okay.
If let me draw here on the side.
Okay.
We covered it in Gaussian. If you have number of spins up and number of spins down is not equal.
Yeah.
So these spins up are referred with red line here, and spin down are referred with this blue line here.
Okay.
Beta and alpha. Make sense?
Yeah.
Okay, good.
So that's why we had some of the orbitals showing 1 instead of 2, right? There was, I mean, I said, was that why we had some of the orbitals showing 1 instead of 2? I remember when we were looking through the list of orbitals, the
yes,
right
yes.
was showing 1. Okay, that's all I wanted to ask.
Okay, yeah, many thanks for the questions. I really enjoyed them. Okay, if you're okay, then let me suggest to complete the session.
Yes, thank you very much for your time, Dr. Killian.
Oh, my pleasure.
Sorry for keeping you for this long.
That's okay. Sorry for keeping you as well.
All right, thank you very much. Have a good night.
Yeah, good night.
All right.